All right, let's work on the inverse of a square matrix. We are on lesson 7-6, and our lesson today is called the inverse of a square matrix, and our essential question says, how do you find and use the inverse of a square matrix? So, in order to do square matrices and inverses, we need to know how to multiply. So it says, show that B is the inverse of A. So the first thing we have to do is we have to take A, B, and we have to multiply them. So let's review how to do this by hand. Remember, this is a 2x2, and this is a 2x2. And when we multiply a 2x2, the inside numbers have to be the same, and that tells us that it can be multiplied. And the outside numbers are going to be a 2x2 matrix. And so remember, we're going to start by multiplying rows by columns and adding. So I'm taking 2 times -1, which is -2, and I'm adding that to -1 times -3, which is +3. And that is going to give me a 1. Now, my goal to find out if it is a square matrix is we're going to have that look of 1, 0, 0, 1. But there does have to be zeros and not just ones, because to know that it's an inverse, it has to look like this. So this is what's going to make it an inverse. All right, let's do row 1, column 2. So I'm going to take 2 times -1, which is -2, and -1 times -2 is +2, and that gives me a 0. Looks like we're getting there. All right, now we're moving on to row 2, column 1. Row 2, column 1 tells us -3 and -1 is 3, and 1 and -3 is -3. Hey, we're there, that's a 0. And now we're going to do the last thing, row 2, column 2. So let's multiply. -3 times -1 is 3, plus +1 and -2 is -2. That gives us a 1. So yes, this is the inverse. B is the inverse of A. For the next problem, they're asking us to find the inverse of A. And this can get a little confusing, but there's a few ways to do it. So I know I have A, 1, -2, -1, and 3. And I know I can multiply it by B. Well, I'm going to call this x11, x12, meaning row 1, column 1, row 1, column 2, x21, x22. And I know that I have to get the 1, 0, 0, 1 out. So if I was to multiply this straight across and straight down, I would have 1x sub 11 minus 2x sub 21. Sorry, I wrote that 21 kind of funny. I want it to be sub 21. And that should equal 1. Then if I do row 2, column 1, I'm going to have the same x sub 11 and x sub 21. But remember that, because we're in row 2, is going to equal 0. So if you look here, I can use elimination, and I have 1x sub 21 is equal to 1. And I could just plug that back in. And when I plug that back in, I get x sub 11 minus 2 times 1, because I'm just substituting this in for here, is equal to 1. And it looks like I have x sub 11 minus 2 equals 1, where x sub 11 is equal to 3. So I'm going to start to build my answer over here on the right, because I'm going to use the right side. So I know that if x sub 2, 1, remember that's going to go down here because that's saying row 2, column 1. And x sub 1, 1, that's going to go up here. So now that I've done the first column, meaning this right here, I now have to do the second column. So I'm going to do the same thing with the second column, and I'm going to show that in a darker blue. So let's go ahead and work on the next column. So this column is what I'm doing right down here. So I have x sub 1, 2 minus 2 times x sub 2, 2 is equal to 0. That's here, 0. And then I have negative x sub 1, 2 plus 3 times x sub 2, 2 is equal to 1. And just like before, I can cancel out, and I get x sub 22 is equal to 1. And I can plug it all back in right there. X sub 1, 2 minus 2 times 1 is equal to 0. X sub 1, 2 minus 2 is equal to 0, where x sub 1, 2 is equal to 2. Meaning that that 2 has to go here, and the 1 has to go here. So the answer to this problem is right here that I'm circling in yellow. 3, 2, 1, 1.